want to get everybody up on board on what we're doing. We're going to try to work on projects for the next month. So what we're doing is we're going to work on RC cars, rovers, robots of all kinds. And in order for us to do that, we decided that we're going to devote the entire month of February. And not only that, but we're going to work on teams. So the next thing we're going to do is show you the schedule, the tentative schedule. But stay here so that you can hear me. The tentative schedule is as follows. This Tuesday, we're here at the Microsoft store. Then next Tuesday, we'll be at the Radio Shack store. And then we're going to be in Valencia. Then we're going to have a night of consultation if we have any questions. And then back at the Microsoft store on the Saturday. All of this information will be posted.
Yep.
And what we're doing is we'll be working on the first 2 nights on the electronics. Then we're going to be working on the mechanical when we go to Valencia. And on that Saturday, we're going to do the communications and so forth. So right now, what we're also going to do, what we're doing right now among all of us, is we have divided everybody into teams of 4. These teams of 4, we asked everybody to decide on what project they're going to do, to give us a team name, and to tell us who the members of your team of 4 are, to come up with a mantra and an idea or category. You're going to do a rover, you're going to do an RC car, are you going to do a robot? So we have a turnaround so which they can see the room. We have put 3 different groups. The first group down there, that's going to be rovers. The ones in the center, right here, RC cars, and the ones right here, robots. And we're having everybody to gather and organize their teams. And in about 1 or 2 minutes, we're going to get the results from them and find out who their members are and so forth. Let me show you one more thing. Let's go back to the schedule. The schedule is going to be the next 4 Tuesdays, and then the next Saturday we're going to work on the communications. All of this will be posted in the meetup. For those that are new to the meetup, I want to refer you to where all the information is. So I'm going to open our webpage here on Arduino. Right here on www.meetup.com, if you do a search for Arduino, electronics, 3D printing and entrepreneurship, you'll be able to find all the information, and you can also join us. And if you just go to upcoming meetups, you can take a look of what we're doing. And what we're doing is this meetup today, this workshop, making your own RC car, rover, robot from scratch, part 1. Now, we're going to do this starting today, as I mentioned. And let's see, is there anybody that you see that they have any questions? If you have any questions from Periscope, let me know, and I'll try to address them. I'm also going to be using this microphone in a little bit, and you'll be able to hear better. Okay, so you guys that are in Periscope can also join the groups that we're going to make. So pay close attention to the different groups that we're going to have, and let us know which group you want to join. Okay, so take a look, go around, and I should be back in 1 minute. Okay, guys, 1 more minute, and then we're going to start organizing the different groups.
I'm trying to keep yourself up. Am I missing something?
I have like getting started. Here's what we're seeing. What's going on down
I wanted to get the guy done.
He's understanding what you're talking, so that's pretty good. How do you zoom out this picture a little
That
bit?
just means that it's a combination of
Yeah, okay.
accelerometers.
Make it light. There you go. I got scripture to it.
They're relatively.
They got a little thing with they call it sidecar, but a little bit of stuff.
I guess it's probably most of it's kind of important, what he's saying, because we've got this on the website, so if you read that.
I was going to fix the artwork and have him start
Really crazy option that would probably require a 3D printer.
set up time.
Well, man, this year we did try to get a BB-8. That's the big fad right now. It's a lot of the same stuff because that's what BB-8 drives like this. It's just all inside of a ball. I would say it's more advanced than that.
Yeah, that's probably
5 years.
There's a British dude that's built one that's really cool. It's like a third version.
I think you guys see something like this. That was after 3 years of spinning. Yeah. Well, like you said, if your rod's back, then you can just put it in the tire.
I'm just looking at it as if it doesn't work, then it falls over.
We got one at Family Lab in the back.
Yeah.
4 by 4 foot, and it has a wood router.
You guys are all familiar with Make Bags, right? So, I don't know, we should probably. You guys are all in on those. We should probably exchange information on that stuff and just send it out there.
Yeah, it's
So you don't have to be
I tried it, not very hard, but
So you guys said you'll overdrive on one side and override the turbo. I'm a software engineer. Oh, nice. So yeah, that part I think we got
one show I watched sometimes. I said, oh, it's 55, I'll take it.
John Paul brought in probably half of that stuff.
Throw some in.
Okay. I live in Orlando, like Rover, this is.
put a bolt right in the middle. that, but it's not stable. It's like,
I'm 10 minutes to downtown.
I'll be new students when we're
other hobby.
although I have a feeling, I'll be knowing you guys for a lot of engineering.
Okay. All right. We're going to start naming some of the groups.
CEO.
Okay, we have 3 categories that we're going to have the groups on. First one, RC cars. I'll just say RC right there. Then we're going to have Rover and Robot. Okay. So let's go ahead and get started. Let me see how much you guys have organized until now. By now you should have an idea of which of these 3 you want to do. You should have an idea of maybe a couple of the people around you, friends that are going to be your teammates and so forth. So let me ask you, in the RC category, how many people are there? Raise your hand. 1, 2. Anybody else doing an RC car? Okay. So you guys came up with a name for your team?
Orlando Speed Racer.
Oh, wow, that's very nice. Orlando Speed Racers. Excellent. So we got 1 team right there. And how many members you have? 3. 1, 2, and who's the other person? 3. Okay, excellent. So if you guys can write down the name of your team and also the name of your members. Okay, 1 second. Okay, let's go for the Rover. Who's interested in making a Rover? Okay, right there. You 4 guys. What's the name of your team? Super what? Super Rollers? Oh, Super Rover. Okay, like Superman, but Super Rover. Excellent. 1, 2, 3, 4. Write down the name of your team and the name of your of each one of you, and we'll go into detail on the different titles and members of your team. What about the robot? Anybody else for Rover? Nobody else Rover? Okay, robot. Let's start right here. How many you got in your team? You got 4. What's the name of your team? TBD. To be determined. TBD team. Excellent. Pretty good. Nice. Okay. Another robot team in the back. But here in the front. Okay. How many you got?
We have 5.
5. Excellent. What's the name of your team?
Team Faceplate.
Team what?
Faceplate.
Face?
Face plant.
Plant.
It's when you fall face first.
Oh, face. Okay. This robot, right? You guys building a robot?
Yes.
Face? Like this? Like plant?
Right, like a plant that grows.
We think it's a robot. It's going to be us balancing.
Okay. Yeah, we can talk about the details. Excellent. So we got 1 team, we got a 2nd team, we got a 3rd, 4 teams so far. You guys in the back? You're going to be building an RC, a Rover, or a robot? Robot. How many are in your team? 4. Excellent. What's the name of your team? R2D2. Wow.
Oh, sweet. Where'd that come from?
R2.
This is like Portal.
Two,
Every
like
time I
that?
destroy a chair, another one
Like that?
came out of nowhere.
Excellent. So we have 1, 2, 3, 4, 5. 5 teams. Anybody else right here?
On our team, we're going to build a balance.
You don't even know what we're doing yet. You have no idea what you're watching.
It's like we're second. We show you our team.
We can make that one of its modes. So like, team face plan. We're like, okay, face plan.
Okay. So we have 5 teams. Is there anybody that has not made it to a team yet? Well, we have people on Periscope. We have several of them that would love to join the teams. Can you focus right here on the whiteboard? There's one team doing the RC car, Orlando Speed Racers. And how many members do you have? 3. So they could use another one right here in the back. Can you turn around and show them who the Orlando Speed Racers are? Raise your hand, the Orlando Speed Racers. Excellent. Oh, and in the back of you, turn around. Right there, Robin too. Excellent. So they have 3 members. The Super Rover, raise your hand. You got 4 of you. Okay? There's 4 members. Can you show the Super Rovers, please? You guys raise your hand. They're making a rover. Okay? Let's take a look at the TBD, the to be determined team right here. How many members do you have? 4. Okay? They have 4 members. Faceplant. Right here. How many members you guys have? 5. Okay. 5 members. And the R2D2, you have 5 members as well. Okay? So, for those that are in Periscope, we have several people that couldn't make it today. They might join some of your teams. For example, the Orlando Racers, they could use 1 or 2 more people. It's okay to have 5. Then the Super Rover could do 1 more, and then 1 more maybe in the to be determined team. Excellent. Very, very good. So what I need from each of the teams is a sheet of paper with the name of the team, the name of the members, phone number, and email, and put the category, RC, Rover, or Robot in there. And now we're going to talk about the different roles, the different responsibilities of the team members. You're going to try to divide the work among yourselves in such a way that you work efficiently. Okay, so let me go down here and describe a little bit. The CEO. One of you will be considered the CEO, the president of your team. You will help keep the vision alive of the RC, the Rover, the Robot. Remind your team they might want to change things as they go along. If all of you vote about it and you want to change direction, change categories, you're welcome to do that. We're very early in the stage, but try to stay focused on what you're doing. The CEO will help keep the vision alive and give direction to your company, your team. You would also find resources needed to succeed of your team. For example, hey, we need some wood. Oh, you know what? I have a buddy that has a wood shop. Or let me ask around. You go get that wood. Oh, we need a 3D printer. Oh, I wonder where do they have 3D printing for free or what resources? You know, the CEO is looking out ahead, setting the direction of how the team is going, and you know the schedule already. So something like that. And you're trying to find all the resources needed for the success of the team. That does not necessarily mean that you have to provide everything, but you just finding the ideas, making the connections, and make sure your team works together. The Chief Financial Officer, which is another member of your team, so start thinking which of these positions you want to fill. We'll make sure that you have the funds necessary and keep a budget. It could be an Excel spreadsheet on the funds. That way you can give a report at the end that says, hey, I built this. When you do your presentation, it costed us $300. We use recyclable materials, and we bought this here and this and that. So then you can replicate the same thing. So the CFO will keep a budget of things, and will tell everybody else how much things are costing, so everybody can chip in and go ahead and get things going. Then we have number 3, the Chief Operating Manager. He gets things going. He's the motivator. He's the one pushing. It's like, when are we going to meet next? He's the one saying, oh, we need to get this done so we can be on schedule. He works along with the project manager. Now, the Chief Operating Manager and the project manager could be the same person if you have a 3-person team, and they keep a schedule of what's going on. If you need to order parts, it takes 2 to 3 days, maybe take a week. You need to start working on ordering parts, on purchasing the parts that you need. All of you will work together with the rest of the team to find ways to keep the project on time and going. And then we have a 5th person, or it could also be one of the persons in the team that's responsible for the media, the video production, to keep in notes on what's going on, how far you're doing, so that you can tell the story. Because when we meet next month on March the 1st, we're going to watch a video of what it took for you to build this. This will be an awesome thing for each one of you to have, because it will give you a perspective later when you do other projects on how long it took to create this little RC car, this Rover, this robot, and what effort you needed. And it would, not only that, it would motivate other people to do the same thing. Maybe it becomes very easy for you to do it. And we're going to have lots of fun. We're here to have fun, not to be serious about things. And when we're sitting and we're eating this beautiful dinner, maybe getting an award or whatever we're going to do in the party on the March the 1st, we're going to be watching our videos and watching our creations. So that's the plan, that's the vision that we have of how we're going to do that. Okay? What I ask all of you every time we meet from every Tuesday is to report the progress of your project. Tell us how much it's costing you, what schedule are you following, how are you organizing, and so forth. So by today, I need the name of the team, the name of your members, and right now work on the titles and responsibilities. Who's going to do what in your team? And come up with a team mantra. A mantra is not a mission statement. It's something like, to empower other people to learn. That would be a mantra. Or my robot is going to save lives. You find out your own mantra. And it's got to be a small phrase that you want your team to adopt. That way you stay focused on what you're doing. So work on these 4. I'm going to zoom down. I'm going to keep that up. The name of your team, the name of your members, adopt the title responsibility, team mantra, and tell me what's the vision of your creation. What features would you like to have? What size you're thinking? And the purpose of your vehicle. What value for humanity? What problem it solves? And number 6, skip number 6. That's too much. Right now, let's do 1 through 5. We're going to do that for the next 10 minutes. Any questions so far? Okay, you guys go ahead and gather around. I'm going to put some music, and I'm going to take away number 6. Go ahead.
Questions. So they got an answer.
over no Rover has gone before. Steal a little bit from Star. That's just the first thing that came to my mind. Anyone else has any other ideas, let me know. I think like a super idea. Yeah. What do you think? It's good. Good to mention. I've only over no Rover has gone before. Like I said, I just grabbed someone from Star Trek. The first thing that came to my mind. The structure is just like Tesla. You know, the size. That's the problem. I see. I have a lot of electronics. So tell us
You have a, see, for you guys on Periscope, you've heard of what we're doing. Right now we're working on the teams that we're creating so we can make this RC car, this robot, or this rover. So far, let's summarize what we got. We got one team doing the RC car, another team doing the rover, and three teams doing a robot. And right now they need to come up with a name of a team, name of the members, titles and responsibilities, team mantra, what is the vision of your creation, what features would you like to have, the size, the wheelbase, and the purpose of your vehicle, what value for humanity it has, and what problem it solves. So everybody's talking about themselves. Try to go around and try to show everybody what they're doing.
Well, but I mean, it could be a good opportunity to kind of see things.
Yeah.
This does incorporate a lot of different really interesting things. There's definitely Arduino at the middle of all this. Motor drivers.
Okay, we got about 5 more minutes, then we're going to ask you for the answers to those 5 items, 5 questions. Thank you.
One says she wants
to join the team? Okay. Hey you guys, I know you're on Periscope watching us. Tell us which team you want to join and we'll put your name there. Okay, let's go to the board for a second. What does it say? Okay, we have these 4 teams, 1, 2, 3, 4, 5 teams. The Orlando Speed Racers, the Rover, Super Rover, 3 robots, to be determined name, Faceplant, and R2D2. Which team do you guys want to join? Tell us your name, write down, text your name, and which team you want, and I'll go ahead and incorporate you. RC or robotic. Okay. Alright, Sad, you say that you want the RC or robotic, right? So, right here we're going to introduce Sad. Okay? Alright, who else wants to join the team from Periscope? Let me know. Let me go ahead and read what you guys type.
Half rover, half robot, licensed to
No problem, Seth. Anybody else from you guys that are watching us on Periscope wants to join the team? Let me know. Was there another person? Try to read what they said, their names. Okay, one more time. We already have you sat in a team with the Orlando Speed Racers. Now, anybody else wants to join, please go ahead and type right now so I can go ahead and put your name and then get you connected. Okay. Okay. These guys are the teammates for Sad. Sad is an engineer. He wants to join your team in Periscope. You guys said 3. You agree?
Yes.
Excellent. Well, go ahead. All right.
Can he post his name and he wants to and his address because we're collecting email.
Right. Okay. I'll provide that information for you guys later. Okay.
And I'm going to set up a mailing list and a website for this project.
Oh man, look at that! This guy's getting really organized. That's awesome. Okay, so Saad, these are your teammates. Go ahead and pen and show them, and I'm gonna get you connected. Okay, he says he will post it for you guys. The meetup. Sure. Okay, guys, one more minute.
And I'll email you this tonight. Okay.
One of the questions is, what is the wheelbase? Let me give you an example what a wheelbase size is. If you have a car and you're looking from the side, here's one wheel, here's the other wheel. The wheelbase is the distance between the two wheels. So that way you can get an idea how big your car or your Rover is and so forth. So this distance is the wheelbase. You want it to be 10 inches, 12, 15, how big you want it to be. We want to know the size of your Rover, your robot, your RC, and this is something you can use to measure it. And how long it's going to be and how wide. So this would be kind of like where your wheels would be if I'm looking from the top. This is your car right there, or face. How long or wide is going to be. Try to talk among yourselves. Some of you may be thinking, I want something gigantic. I can carry all my stuff for picnic, and my robot will follow me and take my picnic table, my beach umbrella, or something like that. Or you want something small that you can just go into places. So think about that. How big your car is going to be, how long, how wide, and what is the distance of your wheels.
What do we probably be thinking? I guess first thought in my head was just kind of thinking about getting around in Arduino.
And it divides into 6 screens.
Yeah, the second one, they said everybody. The guy speaking
This is similar to old phones. Programming what?
You're the programmer. You mean how to download for a project?
There's one that's supposed to be a little more simpler out there called Corona.
They didn't have all the. Yes, they should send it to users
Yeah,
But see, that's more. The idea of a Rover is it goes places without the. I'm thinking about something like.
But what's going to be benefits?
I'm thinking about something like that's not on. Are you building or Melbourne?
This place goes fab. I went last week.
actually put medical sensors on it. You can actually put a whole variety of
Show some close up. All right, guys. Before we get started, let me show you a couple things so you can get more ideas. This is a small robot that my son built. This is very simple for you guys that are doing robots. It's got 3 wheels, 1, 2, and the one on the bottom. Polly, if you're there, come here and show your robot. Polly is a first grader. He assembled it all by himself. How long did it take you?
It's 3 minutes.
Only like 3 hours.
No, I took like a half an hour.
Half an hour. You follow all the directions and so forth. This is an awesome... Oh, you want him on your team? Okay. You can join one of the teams. Hold on, Polly. This is very simple to make. You only have 2 motors. Let's take a look on the bottom. These 2 yellow, and they control the wheels. Now, if you turn on one motor, the car goes on one direction because the other one stays steady. Or if you turn the other, it goes the opposite direction. If you want it to go forward, you have to power both of them. Something very simple. This one follows a line. It has 2 sensors. I'm sorry, I was telling you back. This is the front, and it follows a line. But if you put a transmitter and a receiver, then you can make this remote control. So this is a very simple car that anybody can build. If you look on the bottom, it has an Arduino Uno board. On top is a motor control board. So for you guys that are building robots, this will be one of the most simplest type of a robot to build. These yellow motors we're going to use today and power them.
This is doable.
If you like 3D printing, well, before we go into this 3D printed car, if you look at the chassis, it's all made with these little pieces that you can just buy and assemble, almost like the Lego. I don't know what you call this type of method. What are they? Erector set, and all held by bolts.
Like if you go make an inverter, yeah, like see how you
This one is a 3D printed car from ground up. Very interesting because it has a motor, gears 3D printed, even the wheels are 3D printed, and here a 9-volt battery can be incorporated, and all it would need is an Arduino Micro or Nano, which are the very tiny ones on top. This one does not have the steering done yet, but this can be done. When we go into the mechanics of it, you'll be able to work on the chassis and the suspension, and I'll help you with that. You can build a car that is fully direct. You can go right or left, direct. You will have direction, and so forth. So start thinking. You want a car that's totally 3D printed. You want to build from little metal pieces or other materials, and so forth. Okay, so let's go ahead and get reports from you guys. Let me grab the marker. There's we already got the name of the team, other than the to be determined. To be determined team. Did you guys come up with a name? Did you guys come up with a name yet? Sage Plant. Who's the to be determined team? Right here. Did you guys come up with a name? Yeah? Okay, not yet. Okay, no problem. All right. So let's say the name of the members and responsibilities. So let's start with the Orlando Speed Racers. Right here. You guys, who is going to be your CEO?
We're sort of a co-equal team until we get a better feel on what we're doing.
Okay, so you're going to still work on, okay? Any offices you determine or not yet? Okay, no problem. Any team mantra? Have you been working on anything?
Just like Tesla, only cheaper.
Just like Tesla, what? Only cheaper. I like that. I like that. What's your vision? What do you guys are going to try to make on your Orlando Speed Racers RC?
It's going to look like a regular street car, probably about yay big.
How big? Like 15, 12 inches? 18 inches long. Okay, that's going to be a pretty big one. So 18 inches. Okay, excellent. Anything else you want to add? Any purpose your vehicle will serve? Any value to humanity? Any problem it will solve?
No.
You're still working on that? Okay, no problem. Okay, let's go with the Super Rover team. Raise your hand. Where are you at? There we go, in the back. Please point them out. We got your team name. Have you decided the different responsibilities? Who's going to be CEO, CFO?
I guess I'm CEO.
Okay.
His finance.
Finance right there. Excellent.
Project manager.
Project manager. And op-
Yeah, she's the project.
okay.
Yeah.
And then
It's media.
which one? Media.
The date.
Excellent. Perfect. Perfect. And what is the vision of your creation? What are you guys going to be making? How big is it going to be?
Tentatively, we're figuring about a 1 foot.
1 foot. Oh, the size of that box? You zoom in there? About that big. Okay, what else?
We're being very flexible about this, but tentatively we'll figure about a 1 foot wheelbase.
Wow, that's going to be a pretty big Rover. What's your vision of your creation? What are you going to fulfill? Anything that is going to solve any problems?
We're thinking about like hazard detection, so that we can roam around the building, see if there's any hot spots, gas leaks, radiation, anything like that. And then Wi-Fi back and say, you know, this wall seems to be getting very hot here or something. Send the fire department or something like that.
Excellent. Very nice. Very nice. Okay, perfect. And let's go ahead and go with the next team, the to be determined team. Where are you guys at?
Right here.
Right here. Okay, what is the... Do you have any mantra?
We're going to have fun.
Yeah.
Wow, that's one of the best mantras. We're going to have fun. What about name of the responsibilities? Who's going to be CFO?
I don't know. I just kind of figured I would be the science officer.
Okay. What about the financial?
Between everybody else.
You guys? You two guys? The broke college students? Excellent. What about media or project management?
Project manager and product officer, and these guys will handle media and products.
Excellent. Media and perfect. Very nice. What purpose is your vehicle going to serve? Any value to humanity? What problem it would solve?
We're going to have fun.
Okay, excellent.
But we knew of all the types of sensors could go on it. We're going to load ours up with sensors possibly. If we can get it to run, we'll be happy.
Wow. Very, very nice. So we're going to have some sensors here, some sensors going on as well. Excellent. Let's see what's the next team right here. We have the face plant right in this side. Okay, guys. I know you've been like thinking deep, and you have a great expectation. I have great expectation for you guys. You're one of the biggest teams. What are the responsibilities? Who has what responsibility in your team?
Would you like to introduce?
Well, I'm the engineer. You're the CEO. You're a videographer. Alex is videographer.
Awesome.
This is Ashton, by the way. Sean, what do you know?
What is your role here?
I'm the project manager.
Project manager.
He's the one that should be having the microphone.
Okay.
And
Other Sean.
yeah, I know. I'm trying to remember your role.
Yeah, the CFO.
CFO.
Excellent. Very, very nice. You guys look like you're getting very organized. Any vision of your creation? What feature? How big is this going to be? Is it going to be a small thing, big, huge? What's in your mind?
Ambitious, but rubbish.
What are we talking about?
No, I think we're...
Well, I figured at least this way.
Like 9 inches, 10 by 5, something like that?
Basically big enough to cover all the components. So.
Okay, big enough to cover all the components. Okay, excellent.
And a disco ball head.
What?
And a disco ball head.
And a disco ball head.
Because the CTO said so.
Oh, wow. Excellent, excellent. Okay, and what purpose is going to serve? Just to have fun?
Just to have fun.
Okay.
Hey, that's our idea.
Excellent. Yeah, it's okay. You guys are doing the
We're
same
suing
thing.
them for copyright.
You're suing them for copy. Excellent.
Open source, man.
Yes. And the R2D2 team right back there.
It's a Creative Commons mantra.
Let's go back to them and see what they say. Okay, you guys. Wow, you got something already going? Oh, we're done. All right, you guys. You're done. You're quick. Okay, tell us a little bit about who's going to be the CEO, the CFO, historian, PR, and so forth. Who wants to take the mic?
The CFO, the CEO does.
There you go. Okay.
Oh, you're the CEO.
Go ahead.
All right, so I'm the CEO. We're still pretty new. We're trying to figure everything out, but we glad to have it going. So we're building
We got 6 of us now.
6 of us.
We got 6.
Wow.
Pretty
6 on our
nice.
team.
Yes, welcome.
Okay, so our vision is to go to Mars and have a live stream so we can see what's going on Mars.
From Periscope?
From Periscope with the iPhone. With the Android, because we all have Androids.
So who else is, you are the CEO, who's the CFO? He is, okay.
Yeah, CFO Eric.
Who's going to be the project manager? And
That's me.
That's you, project manager right here. Okay. What about what are the other ones that
We
you
got 2 historians.
Who-
Him and him are going to trade historians.
Historians, media, making the video. Okay. And
Gopher.
helper. Excellent, excellent. What problem you going to try to solve, or what are you going to do for humanity? Very philosophical here. Or you have a mantra. You already have a mantra? Come on.
We don't have a mantra now.
You don't have a mantra yet? Okay, but what problem are you going to try to solve?
Some extra planetary exploration.
Exploration of new worlds.
We
Very
got
nice.
15 centimeter square base, wheelbase.
15 centimeter wheelbase. Okay, excellent.
Yeah, that's
That's it. Excellent. You guys have it figured out pretty good. A question?
Can I make my own team?
You want to make your own team? We still early enough that anybody that wants to make their own team can do it. And so let me know, you guys from Periscope or you cameraman as well. Okay. Excellent. So everybody's got a team. You got a vision of what you're going to do, and so forth. Excellent. Very, very good. All right, we're going to get started with a hands-on part of our meetup. And this is what we're going to do. I don't know about you guys, but when I was in kindergarten, I loved to do what I'm about to show you. Can you tell what am I going to do? Yes. Legos. Oh, that's the next best thing I like. But before Legos, there was Play-Doh or Play-Doh. We call it plastilina back in Spanish. Here I have Sculptex, which is a professional grade Play-Doh. It's sulfur-free and it never hardens, and you can do all kinds of things. Today we're going to get our hands dirty with this, and we're going to make a wheel, just a tire, something very simple. I'm going to show you how to do it, and hopefully this will help you vision and create things. We're going to use 2 things. We're going to use this Sculptex, and we're going to use toothpicks as tools. Let me show you some of the results that I got from my own. Right here, take a look. I have a little wheel that I just made. Okay? You can get as detailed as possible. And here I have part of the steering system for this wheel. Let me show you the other one that moves a little bit better that I have right under here. The wheel turns and this goes right and left. What playing with the Play-Doh Sculptex enables you to do is to visualize movement and action of things. You don't have to do this part. We can 3D print this later and create this part for your going left or going right of your car. But I want you guys to work on this wheel. So I'm going to give you a piece of this Sculptex. Try to put a piece of paper underneath because this leaves a little bit of oil and we don't want oil parts here. And I'm going to show you how to do this in the next 10 minutes. Then you're going to take this with you, and when you get home, you're going to convert it into your idea. How my car is going to look like. Is it going to be high up in the air like this? It's going to be more aerodynamic like this. It's going to look robotic like this, and so forth. And this will enable you to get your vision more in a material way. So we're going to work this on teams. We have 5 teams. I'm going to give you 5 pieces, and each one of you divide that piece into one little ball that you can make.
I'm gonna have my teammate there.
Which one you going?
Where's the?
Well, that's if we're gonna. Not that we need to, but if we're gonna use my motorcycle. Well, because the motor shield like that works.
I mean, given that after matches are still going to have
It smells like leather and fries.
Okay, so every team should have a piece of Sculptex Play-Doh per se. Now what you want to do is divide this piece among all of you. If you have 5, divide it on 5, on 4, and so forth. You can use a knife or you can just rip it. Now make sure you put a piece of paper underneath so that you don't make it a mess in there.
How many you got in your box? You have somewhere to park we can hook up, or how many?
I don't know. I think everybody does.
Everybody has a toothpick. You're going to be using a toothpick to carve your wheel as well. One more member has been added to the RC team. So you have 3 of you, and then Paul, John, wants to also belong to your team.
No, I want to make my own team.
You want to make your own team? Okay. You got to find more members then.
Why?
So there might be another team coming up. All right. If you guys have already divided, you ready to go? I'm going to show you how to do it. Basically, grab a piece and make a hole. The harder you work on it, the softer it gets. But it never dries. So I'm pushing it, making it so that it's round, and then you can rub it against your other palm. Can I borrow a piece of paper?
I don't even want to tell you my book.
You may want to use the table surface and just go around to make it more round. Try to get rid of any irregularities by rubbing against the surface. Make it as round as possible. That way you get a nice ball. Mine is almost totally round by now, and it's gotten hot from going around. All right, everybody's got a ball or something similar. Go around and check how people are doing. There's almost round. You got it. See, look at that. Here, show the results. Okay, how about you? Pretty nice. Once it gets warm, it gets very easy to sculpt. Look at that. They're working. I like that teamwork. Did you see that? Did you guys see that? Two guys are holding a piece of paper and one is working around the ball. That is teamwork at its best. Excellent. Okay, we're getting ready. You guys are almost ready here. You need a little bit of help, anybody? Okay, right here. A little help.
I can do that. The only piece of hardware is best like we're grabbing.
Yeah, we'll talk about those. Thank you. Okay, so we gotta go from here to here. So after you have a ball, the spherical as possible, you're going to go to a flat surface and you're going to flatten it. So I'm going to put it right here. You can use your palm of your hand or any other surface. Can you turn around so they can see it? And you're going to push down on it. Just enough to create kind of like, what would you call this? Like a cylinder? Like this. Try to make it as even as possible. You can even use another surface. There we go. This is how thick I want my wheel to be. Almost like a, I don't know, monster truck wheel. One of those race car wheels. Everybody has flattened their little disc, the little wheel. Can you go around and show everybody, please? Okay, pretty good. Almost everybody's here. Okay, after you have the wheel, what I usually like to do is I like to create the ram first, and then we're going to create the treads around. So I go around here with my toothpick and create an edge all the way around. And I'm going to show you that how I do it now.
Picture of a thing. People did those motorcycles.
If you take a look, I created an edge all the way around, not too deep.
So just like a wheel driving at the bottom of each.
About that deep. Okay? You're trying to create the rim, the difference between the tire and the rim. Go all the way around, make it as circular as possible.
It would have to be like two. And that part would probably have to be So this is...
Then I make another circle inside there. Okay? So I got that little edge going. Okay, so I put another circle inside that circle. And now I'm going to push this outside all around. So that it looks like there's a ram right there. At the same time, I try to clean it up a little bit. Okay. Now I'm gonna make the holes for the lug nuts. Right across. 1, 2, 3, 4. See those 4? That's where the holes are of the lug nuts. Okay, and I'm gonna get another piece of Play-Doh. Thank you. And I'm gonna make a little ball right here with my fingers. What this ball is going to be is, when you have a rim, they usually stick out from the rim. So after you make a little hole like that, you flatten it a little bit, and then you put it right on top of it. And then after you push it in, the little ball, then you go back and redo those 5 holes that you had before. You can grab more from here.
Well, I mean, I'm trying to pull up to see what they have for driver for.
You in the hole in it. I didn't see this.
Oh, you first do this one around, and then you do this one. Oh, sorry, this one around, and then you're going to make this 1, 2, 3, 4 kind of holes.
Right there?
Yeah, right there. Pretty good. Okay, after you've done that and created that hole on that part, you can start making the treads on your tire. And the way I do it, I usually do it like a V fashion. So I would start right here and go down like that, and then you can do another one on the other side like that, and so forth. It's easier if you do work one side and then come back. Create a little bit of a space.
Before we started actually
I mean, that's probably if we want wrong.
Then you do the other side to even it out. And then you can incorporate smaller cuts right here so that it even looks better in between. And on the other side, and there it is. There's your tire. And then you can make the hole for where the axle will be. There's your little tire. You can get as detailed as possible. You guys keep working on that. I'm going to go ahead and get the circuit started that we're going to build next. And I want to see everybody's tires. You can go one by one. This is mine. And then just go around and you guys show your tires, please. Awesome. Very nice. The only thing you will need is like a little ball that goes in the middle right there. Go ahead. You also need one. You show the tire. I like your tire. Feels even rubberish. Here, this might be too big, but let me give you a little bit smaller. Pretty nice, huh?
Some tread going on there.
Right here, you can put that right there and then push it down.
Drill this
Yeah,
inside.
redo the holes, and then you're gonna put your axle on this side, right there. How about you guys? You got some tires going on? Go around.
I'll put it all down the right side.
Yes. If you want more Play-Doh to create that little ball on the end, let me know if you need one.
I don't know.
The captain. Very nice. It's pretty wide. I like that. You can make a little wide motorcycle. Look, you got the very nice, very artistic. Can you guys show us some of the wheels you got? Wow, pretty nice. Look at that one. A lot of detail. Pretty nice. Keep going around, please, and showing what you have. To make your design stronger, you can use some kind of like a bone system or a core armature inside. Like for example, right here, I use copper, and on top I have Play-Doh, and I kind of created this form where my other two wheels will go around. So as you build more things with this Sculptex, you can put inside wire coil to make it stronger. Otherwise it's going to collapse. Now the one we have is medium. They also sell hard, which is much difficult to play with, but you can use tools to move them around and so forth. Okay, really quick, as you guys are finishing, I know we're about to close here. We have not gotten to the electronics parts, and that's okay, because we're going to go as fast as you guys can go, and we still have a lot of time. I'm going to show you the circuit that we're going to build next week, show you the parts that you need, and that way you're totally ready. Next week, each team or several in your team will have one of these motors and a wheel attached to it. So you'll have a wheel and a motor. And this motor has right here positive and negative that you're going to connect with, and you're going to work with this wheel and motor to make it go forward, backward, faster or slower. So each team will have at least one or two of these or more. And we're also going to hack, we're going to tap into some of these cars. Some of you may have this whole drive system. You have a positive and a negative right here. All you have to do is tap into these two to make this whole system work. So I'll bring some of this. You'll be able to tap into my son's toys. These are his. Or even the back of this and so forth. So we'll have a motor. So let me go ahead and erase this, and we'll go ahead and write down some of the parts that we're going to be using and draw the circuit. Okay, so for next week, you're going to have your Arduino Uno. Which is depicted right there. I'm going to go ahead and put together the circuit so you guys can see it. Let me go ahead and grab one of these so that I can have a more accurate look. How is it going to look? Okay, so you'll have an Arduino Uno. Right here is the microcontroller part of it. Then you have one set of connectors, then you have another set of connectors, and then you have headers right here and right here. Here's where you will connect to the computer. So this will go to your laptop. Through USB. And we're going to work on pin 9. So from pin 9, we're going to be sending a signal with a resistor, a 1000 ohm resistor. From there, it's going to go to a transistor. Here we have the base of the transistor. We have the collector and the emitter. The emitter is going to go to ground. The collector is coming to this circuit where we will have three things. Here you will have your motor. Here you will have a capacitor and a diode. The purpose of this capacitor and this diode is to protect the entire circuit from spikes and so forth. And this is going to connect to a different power supply than the one for the Arduino. So if your motor runs on 5 volts, it's going to be a 5-volt line, separate line than the one that is feeding the Arduino, because the Arduino does have power and ground. And this ground of this circuit is going to also connect to a ground that you find in the Arduino. And I believe there's a ground right there on pin, where pin 9 is as well. On that side, yeah, it's more on top. So right here on your Arduino board, there's a GND, which is ground, and that will connect right here to this ground. So basically, this is the entire circuit that we're going to use next week. I'm going to put here the parts that you need. First, an Arduino Uno. Second, you will need jumper cables. Jumper cables. You will need a 1000 ohm resistor. You need a transistor. There are two transistors. One is the 2N 222, which is a less power transistor. Or you can get, if you need to move a high power motor, you can either use this one or the more powerful one. It's going to be a tip 120, which is also called a Darlington transistor.
You're missing a 2 on the 2N222.
Yes, thank you very much. There's 4 2s and an extra one. This one is very highly available everywhere. I have extra ones. If you cannot find one, don't worry. I probably have about 200 of them. The tip 120, I also have a lot of them. If you cannot find this, I'll bring some extra. So we have taken care of this. Then we have the motor, which I will provide, or you can bring your own, and we'll have plenty of these motors here. And I'll bring a capacitor and the diodes. And I'll go ahead and post the values of this and which ones they're exactly. I think this is a 1 microfarad. And something I would like for you guys to also get is one of these power cords. This is a variable, so you can get all kinds of voltages. This gives you anywhere from 3 to 12. They sell this in many Radio Shacks. If you cannot find it anywhere, also Skycraft. It's about $7 to $9.
You need a variable one?
A variable one will be better. If you don't have a variable one and you have the voltage that you're going to move this motor is about, let me see, this is 6 to 9 volts it takes to move this. If you already have a motor that you have in mind, then get a power supply like this for right now. Or you can use batteries, just like here. 4 of these are moving this motor, and this other battery are moving there. But batteries, they wear out and you'll have to buy more and more. So for right now, get one of these and have it in your kit. That way you can use this power supply, not to power the Arduino, because the Arduino will be powered through your computer for the moment. but this will be to power this whole circuit, these 5 volts that we're talking about right here. I have some extra ones. I have about 3 of these or 4 of these. If you cannot get one, you can borrow from us. And I also have tons of this. If you want to borrow one of these or 2, this case is for just buy the batteries. But bring the batteries that you need to move the motors next week. So this is basically how it looks. I'm going to put the Fritzig version of this, which is much clearer and simpler this week. If you have any questions, let me know. The next step after moving this motor and the speed is going to be to make it go forward and then backward. And to do that, we'll use an H-bridge, which is going to be a chip that will have Darlington transistors or MOSFET in this case inside here, and we're going to learn how to connect that. So that's what we need for next week. And if you have a servo, go ahead and bring it. If you don't, there's tons of servos at the Radio Shack we're going to be at, and I also have servos with me that I can right here. This is the standard servo. This will be for going left or right. And at the store they should have some next week, and I'll bring some to borrow as well. So next week we're going to, in summary, turn this motor on and this wheel, control the speed of it, possibly control going forward or backward if we already get the H bridges, and we're going to get started on the servos so that you can make your robot, your RC car go right or left. Once you have managed those 3 things that I mentioned, the speed, the direction to go forward or backwards, the steering to go right or left, then you are about 70% done, or 60% of your Rover. Once you know how to program and do this, you can control the motor, the movement. The next thing is going to be creating the chassis that's going to hold together your whole car. And we're going to use 3D printing. We're going to use 3D CAD to do that, and any other materials that you guys want to use. And then when you have the motor control, the chassis, and we work on the suspension, the last part is going to be creating our own controller through wireless. By that time, you would have everything that you need to do that. I have already done that, and I'm going to show you some of the results as we go along. And let me tell you, it's one of the greatest feelings when you can make something from scratch and see it work in front of your eyes. It's like Christmas Day when you get a gift, or you're waiting for that gift. It's incredible. So I would like to encourage each one of you to please communicate with your teammates, exchange phone numbers, information, talk about the ideas. Next week when we meet at the Microsoft store, it's going to be all electronics, hands-on. Today we couldn't get into that part. At Radio Shack, I'm sorry. Yeah, next week. Thank you. Any questions so far?
Address?
The address. We're going to post the address, but we might as well just look it up. It's right there on Orange Avenue near Cayley. And let's go ahead and Google it. Here we go, 2001 South Orange Avenue. And they're going to have pizzas for us, I believe, and some sodas in there. So we'll have a lot of fun, and then we'll be able to create great things. Thank you very much for coming. I'll stay here as we wrap things around. If you want to take a look at the Arduino Uno, for those that don't know how it looks, what it is, and all the parts, I'll show you that. And if you have any questions or whatsoever, please let me know. Thank you. We'll see you next week.
Because you gotta make whatever changes you want. Plus, I was trying to make things talk.
Any questions from you guys from Periscope before we go ahead and end the broadcast? Before we do, some people that have been watching us and following us, come a little bit. I'm going to show the web page from where anybody that's watching on Periscope can find the information of what we're doing. The name of our group is Arduino Electronics 3D Printing, and we're here in Orlando, Florida. And we make awesome things. We use Arduino as the main platform to create things, electronics and 3D printing. If you want to join us, just do a search on www.meetup.com. When you do that, search for Arduino, electronics, 3D printing, and entrepreneurship. And you'll find us. There'll be a button that says join. And once you join, you go up to upcoming meetups. You click on that, and it will tell you what we're doing next. So right now, today's Tuesday, February the 2nd, and we have done making your own RC car, Rover robot from scratch, part 1. Next week, we're going to be at the Radio Shack store on Orange Avenue in Orlando. The address is 2001 South Orange Avenue.
Little LCD display that tells you your temperature and your battery level and your
And what we're going to do next week is we're going to make a motor move. Let me show you the motors. Let's go down there.
best thing to do.
We're going to make this little motor move with this tire. We're going to use an Arduino board to control it, and we're going to make it go forward, and later we're going to, with an H-bridge, we're going to go forward, back, and then we're going to use a servo, which is inside here, and it's going to make the front wheels go right or left. And we're going to continue the projects, part 2, part 3. We're going to be at Valencia College, and there we're going to do all the chassis, the mechanics. We're going to try to create a 3D printed parts, just like this little car, that it can hold the wheels, the motor, gears, and then we're going to put the battery and all the other parts that need to be there. And the last part of our project, we're going to do the communication. We're going to create our own joysticks, controller, just like this, with an Arduino board, and this will control the car going forward, backward, left, or right. Anyway, see you guys. I hope you can join us next week on Tuesday, 6:30. Have a great day.